I have another Higgs video here. I believe this is more research on my theories, and this is low energy positron beams Higgs boson Tesla's CLIC collider. So August 20th 2012 is when I was working on the research. Today is November 16th 2012. So the first thing I did was Google high longitudinal polarization, and I found a Google link for it. So data quotes is high energy physics experiment measurement of low energy longitudinal polarized positron beams via a BHA polarimeter from Gideon Alexander and Erez Aranis in 2005. The introduction of a longitudinal polarized positron beam in I don't know why it does these number signs, but I think it's whenever you get the information from them they do that. Linear collider calls for its polarization monitoring and measurement at low energies near its production location. Here it is shown that a relatively simple Bahama scattering polarimeter allows, at energies below 5000 MeV, a more than adequate positron beam longitudinal polarization measurement by using only the final state electrons. It is further shown that out of the 3, 10, 250, or 5000 MeV positron beam energy locations, where the polarization measurement in the Tesla linear collider can be performed, the 250 MeV set is best suited for this task. So it's on high energy physics from ARXIV. There's the file name there. And submission was 2000. Okay, so it's arxiv.org is where you can find it. So I Googled Tesla linear collider to find out what it means, and the quote is from Wiki. The compact linear collider, CLIC, is a proposed linear particle accelerator under development at CERN. It is designed to perform electron-positron collisions at a nominal energy of 3 TeV, and hence to provide highly precise measurements of elementary particle interactions on an energy scale higher than any existing collider. As of February 2012, 43 institutes from 22 countries are participating in the project. That's cool. It's like a world project. CLIC is the competition with the International Linear Collider Project. So this is what CLIC looks like. It's got a drive beam accelerator, delay loop. So just so you know, the formulas that I'll be showing you is how to redesign this little contraption that you guys have built to make it more cost effective and to make it faster. Based on my theories, okay? So it says combiner ring, turnaround, damping ring, pre-damping ring, bunch, compressor, beam delivery system, interaction point, and dump. E- injector, E+ injectors, acceleration 1 gigahertz, deflection 0.5 gigahertz, 180 degree phase switch and SHB, delay loop, even buckets, odd buckets, RF deflector, subpulse length, even buckets. Okay, you get the idea, right? It's got a gap, pulse gap in it. So September 9, 2012. My thoughts. AIRL, or whatever it's saying. So when I say AIRL, that's like an ancient alien astronaut that talks to me when I meditate sometimes. Because I don't think these ideas are coming from my head. If they are, I'm surprised. Okay, so your delay loop needs to change. Diagram on the right. So this delay loop here, this one here, she says that needs to change. Because you've got it going counterclockwise, right? Okay, so signals come from the west and east, meet in the middle of your RF deflector, 0.5 gigahertz, and have the arrows both go up on both sides rather than clockwise. So she says you go this way and this way instead. Okay, the right side goes counterclockwise and the left side goes clockwise. So the signals meet at the top and combine into two simultaneous signals going in two directions at the exact same time. So they will meet up here. Add your cooled liquid argon gas plasma to this mixture and beam the neutrinos through it in the middle as a magnetized signal. The smaller particles will stick to the magnetic beam, and with your 3 flashes, the other video explains how to do the 3 flashes and how to set it up with the camera. See other video on how to do those. You will see the 4 missing particles sparkle. So your 4 missing particles that you're looking for are going to show up if you do this. And we're talking about the standard model particles and the other particles that belong to the neutrinos family. The ones that you can't see at the moment. So this is the drive beam. 2.3 GV, 240 MeV. This is the quadruple power extraction and transfer structure PETs. Main beam, accelerating structures. Quote wiki, the sources for the electrons and positrons of the CLIC main beam are located in the central region of the machine near the interaction point. The positron beam is unpolarized while the electron beam is polarized using a circularly polarized laser, which is shown on a GAES type cathode. Just so you know, there is another invention that comes up in the WOW videos about the GAES type, and it's another new laser beam. It's a new pulse gun thing that's been patented. It's a patent that hasn't been used yet, and it's brand new. So it's something you guys are going to want to look at, cross-referencing with the WOW videos for that. Interaction point and detectors, top view, CUC ILD experiment, CLIC 50 experiment. I can't really read the writing there. It's kind of blurry. I don't have my glasses on. Sorry. Quote wiki, CLIC detectors at the interaction point, movable by push-pull system. One of the main challenges in the construction of a linear collider is the fact that the beams can be brought to a collision only once and do not circulate for many turns as in circular machines like the LHC. I got my glasses on now. This strongly decreases the rate of particle collisions, hence it is necessary to increase the collision probability of the particles at the interaction point for each bunch crossing. September 9th, formula idea. That's from 2012. So these are the things you want to put together. Your CLIC detectors, linear collider, beams, collision. Once need to change this. Again, from the notes back there, how to change it. Does not circulate for many turns as in circular machines, so you don't need to circulate as much. LHC decreases the rate of particle collisions. Increase your collision probability, particles, interaction point, bunch crossing. Transverse size of the beam. Reduced strongly, pinch effect. 40 nm vertically, 1 nm horizontally, CLIC. Okay, so that's your measurements and that's how to do it. Okay, thanks for watching. I'm going to go on to the next video, which is another continuation of this thought.